All students are welcome to next chemistry lecture of types of solids or solid state. In previous lecture of this unit we see first one introduction, then types of solid, first one crystalline solids, second one amorphous solids, then terms related to this classification as isomorphism and polymorphism. Next one, classification of crystalline solids. Next point. In this one, we discuss about ionic crystals and covalent network crystals. Now today we are here going to collect information about next two types of solids. First one, molecular solids or molecular crystals, and second one, metallic crystals or metallic solids. विद्यार्थी मित्रांनो, आपण पाठीमागच्या तासाला क्लासिफिकेशन ऑफ सॉलिड्स मध्ये दोन टाइप्स पाहिलेले आहेत. त्याच्यामध्ये आयनिक क्रिस्टल्स, आयनिक सॉलिड्स, आणि सेकंड वन कोव्हॅलंट नेटवर्क क्रिस्टल्स और कोव्हॅलंट सॉलिड्स. आजच्या तासाला आपण मॉलिक्युलर क्रिस्टल्स थर्ड क्लास and fourth one metallic crystals, just simple properties and example of each one. Now starting with third class of crystalline solids, that molecular crystals. So dear students, here substances like hydrogen, carbon dioxide, chlorine, etc. on solidification give molecular crystal. That is examples that their solid form. Their solid form or on solidification, these substances gives molecular type of crystals. And also crystalline organic compounds such as benzoic acid, fructose, glucose, that is sugars, some proteins, some fats, etc. are also examples of molecular crystals. Now there are some properties of molecular crystals. So first one is of constituent particles. So see, first property, the constituent particles of molecular solids are molecules or unbonded single atoms of the same substance. In this, if we consider the example of chlorine, example of hydrogen, example of carbon dioxide, then the constituent particles here, for example CO2, here constituent particles of molecule of CO2, one molecule attached to another, or for example oxygen is unbonded single atom O2, first molecule of oxygen, second molecule of oxygen, they attach by different intermolecular forces of attractions. So here the constituent particle of molecular solids are molecules, the smallest particle of compounds. Now students, the next important point from molecular crystals are which forces are held together these molecules to form a given compound. So see, second point, the bonds within the molecules are covalent type of bonds, particularly they are formed by share of electrons. The bonds within the molecules are covalent. The molecules are held together by various intermolecular forces of attractions. So there are three types of intermolecular forces of attraction in this one. First one, weak dipole-dipole interactions, examples of HCl, H2, SO2, that they having or they possess a permanent dipole moment. Second, very weak dispersion, or another name for it is London forces. That is, particularly London forces or weak dispersion forces are present in non-polar molecules. For example, methane, hydrogen, etc. That is, these forces are also only in monoatomic solids like argon, neon, etc. These substances, particularly argon, neon, these are usually gases at room temperature. And third one, intermolecular hydrogen bonds in solids such as water, ice, solid water state ice, ammonia, hydrogen chloride, and so forth. So these are three types of forces. So details. What are the intermolecular forces of attractions? between these molecules, how held it together the molecules. These are details seen standard 11th, it's chapter number 10, that is states of matter. हा सर्व पार्ट जो आहे त्या ठिकाणी आपल्याला त्या ठिकाणी 11th स्टँडर्डचं जे युनिट आहे त्या ठिकाणी स्टेट्स ऑफ मॅटर, त्याच्यामध्ये गॅसेस अँड लिक्विड स्टेट्स याचा अभ्यास आहे. तर त्याच्यामध्ये हे डिटेल्स दिलेले आहे. वॉट आर इंटरमॉलिक्युलर फोर्सेस, डिफरंट टाइप्स ऑफ इंटरमॉलिक्युलर फोर्सेस, एक्झाम्पल्स, एक्सप्लेनेशन of this intermolecular forces with examples. So here are three. First one, weak dipole-dipole interactions. The example hydrogen chloride, water SO2. Second, London forces of example methane and hydrogen. Third one, intermolecular hydrogen bonds, for example ammonia HF. So one by one we see different intermolecular forces. That is, first we see there are two types of forces. First one intermolecular and second one intramolecular. What is the basic difference between intermolecular? If you read chapter number 10 in 11th standard books, the details are given in this one. Intermolecular between two molecules. Intermolecular forces between two molecules, and intramolecular forces are within molecule. If we consider a single molecule and the forces present between the constituent particles of that particular single molecule, that forces are termed as intra. And if the forces are present between two different like or unlike molecules, they are termed as intermolecular forces. This is the basic difference. Now, what are these intermolecular forces? The forces are the attractive forces as well as the repulsive forces present between neighboring molecules. There are two types of intermolecular forces. First one, attractive, that is attraction force of attraction. Second, force of repulsion. Two types. Here, the attractive forces decreases with increasing distance between the molecules. If the molecules are in given compounds are so far, the distance is more between these two molecules, then the attractive forces are less, or they going to decrease. The intermolecular forces are strong in solids as compared to in liquids and also in gases. So particularly what are the intermolecular forces is the attractive force of attraction between two or neighboring molecules. And the properties such as melting point, boiling point, vapor pressure, evaporation, these all properties can be studied with respect to the strength of attractive forces between the molecules. So these are the intermolecular forces. So first we see weak dipole-dipole interactions. Intermolecular forces, dipole-dipole interaction, how it is generated. For example, we take HCl, hydrogen chloride, H plus and Cl minus. So polar molecules experience first one dipole-dipole interactions. Polar molecules experience dipole-dipole force due to electrostatics interaction between dipoles on neighboring molecules. त्यामध्ये जर आपण HCl चं जर एक्झाम्पल घेतलं तर त्याच्यामध्ये हायड्रोजन हा त्यामध्ये डेल्टा प्लस इन स्मॉल अमाउंट, it acquires small amount of charge. Also Cl acquires minus charge, delta minus. आणि HCl जर कन्सिडर केला तर HCl मधला Cl मायनस आणि दुसऱ्या मॉलिक्यूल मधला H प्लस, या दोन्हीमध्ये त्या ठिकाणी एक विशिष्ट प्रकारचं डायपोल त्या ठिकाणी फोर्स ऑफ अट्रॅक्शन क्रिएट होते आणि त्या ठिकाणी तो मॉलिक्यूल्स त्या ठिकाणी फॉर्म होते. म्हणजे त्या ठिकाणी पर्टिक्युलरली पोलर विच हॅव्हिंग चार्जेस ऑन इट्स कॉन्स्टिट्युएंट पार्टिकल्स, पोलर मॉलिक्यूल्स HCl, H2, HZ, SO2, these are the polar molecules. So polar molecules experience dipole-dipole forces due to electrostatic interactions between dipoles on neighboring molecules. So polar covalent molecules is also described as dipole, meaning that the molecule has two poles, as we see in HCl. They have two dipoles. That is, for example, HCl, H having delta plus and Cl having delta minus. The covalent bond becomes polar due to electronegativity difference between bonding atoms. So what is the electronegativity? Simply we see in 11th standard is the ability of that particular constituent particle to attract electron towards itself. आपल्याकडे इलेक्ट्रोनिगेटिव्ह आपल्याकडे इलेक्ट्रॉन त्या ठिकाणी खिचून घेण्याची जी पॉवर असते त्याला त्या ठिकाणी इलेक्ट्रोनिगेटिव्हिटी. ही इलेक्ट्रोनिगेटिव्हिटीचा जर डिफरन्स जर त्याच्यामध्ये असेल, ते दोन कन्स्टिट्युएंट पार्टिकल्समध्ये जर असेल, तर त्या ठिकाणी अशा प्रकारे त्या ठिकाणी ही पोलॅरिटी त्या ठिकाणी इंड्यूस होते किंवा हा बॉन्ड त्या ठिकाणी फॉर्मेशन. Hence, polarity is observed in the compound containing this same unit. For example, SCl. Here, one end of the molecule has partial positive charge on hydrogen atom, that is delta plus, and partial on chlorine atoms has, that is delta negative. As a result of polarization, the molecule possesses the dipole moment. That is the electrostatic force of attraction or interaction between these two poles of neighboring molecules, and thus these molecules having possess a permanent dipole moment and formation of molecule. So this is the first one, weak dipole interactions. Now next one, very weak dispersion or London forces. For example, methane, hydrogen, etc. Also examples of this argon, neon, particularly they are present gases at room temperature. So what are London forces? London dispersion forces are also they term as van der Waals forces. Particularly these forces are observed in non-polar molecules and also individual atoms of inert gases, that argon, neon, etc. In this case, non-polar molecules and inert gases only dispersion forces exist. They are also called as London forces due to an idea of momentary dipole which was proposed by the German physicist Fritz London. So these are termed as London forces. म्हणजे त्या ठिकाणी जे नॉन पोलर मॉलिक्युल्स असतात त्याच्यामध्ये एक मोमेंटरी डायपोल, तात्पुरत्या स्वरूपाची त्या ठिकाणी चार्ज डेव्हलप होतात, तेच त्या ठिकाणी मोमेंटरी डायपोल, आणि याच्यामुळे त्या ठिकाणी ते मॉलिक्युल्स किंवा ते त्याच्यामध्ये जे कॉन्स्टंट पार्टिकल्स आहेत ते त्या ठिकाणी एकत्रित त्या ठिकाणी बांधले जातात. So it is the weakest intermolecular force that develops due to the interaction between two non-molar molecules, weaker one. In general, all atoms and molecules are experience London dispersion which results from the motion of electrons. जे त्या ठिकाणी न्यूक्लियस भोवती जे त्या ठिकाणी इलेक्ट्रॉनचे अरेंजमेंट असते आणि त्याची जी मोशन असते त्या मोशनमुळे काय होते त्या ठिकाणी हे जे फोर्सेस आहेत, फोर्स ऑफ अट्रॅक्शन त्या ठिकाणी जे नॉन पोलर मॉलिक्युल्स त्या ठिकाणी त्यांना ते त्या ठिकाणी दिसत असतात. That at any given instant of time, the electron distribution in an atom may be asymmetrical, giving the atom a short-lived dipole moment. This momentary dipole in one atom can affect the electron distribution in the neighboring atoms and induce momentary dipoles in them. आपण जर त्या ठिकाणी एखादा ॲटम जर कन्सिडर केला आणि त्या ॲटमभोवती त्या ठिकाणी त्याचा न्यूक्लियस, ॲटमचा न्यूक्लियस आणि त्याच्याभोवती जे इलेक्ट्रॉनचे अरेंजमेंट असते त्या ठिकाणी, या इलेक्ट्रॉनच्या अरेंजमेंट जे असते ते असिमेट्रिकल असते, एका विशिष्ट सिमेट्रीमध्ये नसते. त्याच्याभोवती जो स्पेस असतो त्या स्पेसमध्ये त्या ठिकाणी ऑर्बिटल्स, तर या असिमेट्रिकल मुवमेंट अरेंजमेंट असेल इलेक्ट्रॉनची, त्याच्यामुळं जो नेबरिंग ॲटम असतो त्याच्यामध्ये काय होते, एक मोमेंटरी तात्पुरत्या स्वरूपाची एक डायपोल मुवमेंट त्या ठिकाणी क्रिएट होते, आणि हाच त्या ठिकाणी तो असतो त्या ठिकाणी इट इज द फोर्स ऑफ अट्रॅक्शन ऑर से लंडन फोर्स ऑफ अट्रॅक्शन ऑर लंडन डिस्पर्शन फोर्स. याचे एक्झाम्पल्स आहेत, ऑक्सिजन असेल त्या ठिकाणी, कार्बन डायऑक्साईड असेल, नायट्रोजन असेल, हॅलोजन असेल, मिथेन असेल, हेलियम एटसेट्रा. So this strength of this force is increasing with increasing molecular size, molecular mass and number of electrons present in an atom or molecule. So these are the second London forces. Now students, third one, hydrogen, intermolecular hydrogen bonds. So how hydrogen bonds are formed, for example, in case of water, in case of hydrogen fluoride, in case of ammonia, etc. So there are two types. First one, intramolecular hydrogen bond. Second, intermolecular hydrogen bond. So what is the intermolecular? Intermolecular we see in details. Intermolecular bonds between two molecules and intramolecular within the molecule. So hydrogen bond is a special type of dipole-dipole attraction which occurs when a hydrogen atom is bonded to a strongly electronegative atom, particularly oxygen, nitrogen, fluorine. These are the strong electronegative atom which having more capacity or strong capacity to attract electrons towards them. So when hydrogen atom is attaches or bonded to this electronegative atom or an atom with a lone pair of electrons, then there is a formation of hydrogen bond. So these hydrogen bonds are generally stronger than dipole-dipole and dispersion forces, but weaker than true covalent or ionic bonds. So it is the hydrogen bond, it is the electrostatic force of attraction between positively polarized hydrogen, that is positively charged hydrogen atom of one molecule. For example, we take HF, single molecule HF, second molecule HF. That is the force of electrostatic force of attraction between positively charged hydrogen atom of one molecule, that is H delta plus, and highly electronegative atom which may be negatively charged of other molecule, that is F minus, delta minus, and thus there is a formation of one bond between H plus and F minus, that is H delta plus F delta minus. Delta is the symbol for represent or presentation of small charges which acquired by the constituent particles or atoms. So strong electronegative atoms that form hydrogen bonds, particularly with nitrogen, oxygen and fluorine. So there are two types. First one, intermolecular hydrogen bond. Second, intramolecular hydrogen bonding. So what is intra? Hydrogen bond which occurs within one single molecule represents intramolecule. For example, ethylene glycol. And second, a hydrogen present between two like same, that is for example HF, it's unlike molecules that represents the intermolecular hydrogen bonding. So students, this is the second property, that is the bonds within the molecules are covalent type. The molecules are held together by various intermolecular forces of attraction, that is weak dipole-dipole interactions. Second, London forces. Third one, intermolecular hydrogen bonds. Now students, we move towards the next point or next property of molecular solids, that because of weak intermolecular attractive forces, molecular solids are usually soft with low, and therefore they are having low melting points, and the forces between their constituent particles are that is intermolecular forces of attraction are weak one or weaker one, so they easily melts, so they having low melting points. And last one, these solids are poor electrical conductors and are good insulators. So these are the properties of molecular crystals. So details about the forces of attraction are, you just read in chapter number 10, that is states of matter, in 11th standard book. Now students, we see the last point or last solid, metallic solids or metallic crystals. So what are metallic crystals? They are crystalline solids formed by atoms of the same metallic element held together by a metallic bond. Here the bond is metallic one. The examples are sodium, potassium, calcium, iron, silver, gold, cobalt, etc. So simply, this metallic bond, how it is formed, and some properties of metallic crystals. In a solid metal, the valence electrons, that is the electrons present in last orbit, are delocalized over the entire crystal, leaving behind positively charged metal ions. For example, sodium जर कन्सिडर केला, कॅल्शियम कन्सिडर केला, तिचं जे ॲटम स्ट्रक्चर असेल तर त्याच्यामध्ये जे व्हॅलन्स इलेक्ट्रॉन्स असतात त्या ठिकाणी ते व्हॅलन्स इलेक्ट्रॉन ते डिलोकलाइज होतात त्या ठिकाणी एंटायर क्रिस्टलवरती त्या ठिकाणी मुवमेंट, आणि हे डिलोकलायझेशन झाल्यानंतर त्या ठिकाणी तिथं तो फक्त त्या ठिकाणी आयन राहतो त्या ठिकाणी त्याचा मेटल आयन्स, फॉर एक्झाम्पल Ca2+, K+, Na+, And here, therefore, metallic crystals are often described as an array of positive ions immersed in a sea of mobile electrons. म्हणजे त्या ठिकाणी हे इलेक्ट्रॉन त्या ठिकाणी स्प्रेड झालेले असतात, डिलोकलाइज झालेले असतात आणि त्याच्यामध्ये ते मेटल आयन्स त्या ठिकाणी प्रेझेंट असतात, म्हणून त्यांना काय म्हटलेलं आहे त्या ठिकाणी दे ऑल्सो टर्म ॲज array of positive ions immersed in sea of mono. The attractive interaction between cations and electrons constitute the metallic bonds. How it is formed? It is the force of attraction between cations and the mobile electrons, that they which are delocalized over the entire crystals, and just they held together to form a metallic crystals. So now, what are the properties? First one, these metals are malleable. What is malleability? Simply they can be hammered into thin sheets. म्हणजे आपण हे जे मेटल्स असतात त्या ठिकाणी या मेटल्स आपण काय करू शकतो, त्या ठिकाणी शीट असते जे त्या ठिकाणी शीटमध्ये त्या ठिकाणी त्याचं कन्व्हर्शन रिफॉर्मेशन आपण काय करू शकतो, त्या ठिकाणी कन्व्हर्शन करू शकतो. नेक्स्ट वन, डक्टिलिटी. मेटल्स आर डक्टाईल, दॅट इज दे कॅन बी ड्रॉन इन टू वायर्स, थिन वायर्स. आपण त्याच्या वायर्समध्ये हे मेटल त्या ठिकाणी काय करू शकतो, कन्वर्ट करू शकतो किंवा त्याच्या वायर ड्रॉन करू शकतो. थर्ड वन, मेटल्स हॅव गुड इलेक्ट्रिकल अँड थर्मल conductivity. So examples are the metals are potassium, lithium, iron, silver, gold, copper, etc. So students, we see second classification of crystalline solids. Crystalline ionic solids, covalent network solids, molecular solids, metallic solids. The summary is given in your book on page number 5, it's table number 1.1. Properties of 4 types of crystalline solid with reference to properties, that is particles of unit cell, second interparticle forces, third one hardness, fourth one melting points, fifth one thermal and electric conductivity, and examples of each one. So you just read in details these properties in details. So thank you students for joining today's lecture.